This paper was presented at the JCT Traffic Signal Symposium 2025. Video coverage of this paper is provided by Highways News and sponsored by Mobius Networks, AGD, smartmicro UK, TRL Software, Traffic Group Signals, AD Electronics, and Four-Way Consulting.
Yeah, again, he keeps stealing the thunder here. I was going to say, this is Nigel Taylor behind the curtain or somewhere. I don't know where he's gone, but I'm going to do his bit. And please bear with me because I'm not a traffic signals engineer as such, which he is. But I'll do my best to do his little intro on this. Okay, what's a traffic headache? I looked it up the other day, and it says a persistent issue that causes confusion, delay, or danger to drivers, cyclists, or pedestrians. So, without further ado, then let's look at the Marsh Mills roundabout. Okay, for those of you who don't know Marsh Mills, it's a roundabout. It's the largest and busiest roundabout in Plymouth, in Devon, and it currently handles somewhere around 35,000 vehicle movements a day. Can you hear me, by the way? Because I can't. Yeah, you can. Okay, fine. It handles 35,000 vehicle movements a day, and it's a key access point within the boundaries of the city. The iconic Sainsbury sales, as they say, are there, and most of you, if you travel down to the West Country, you've probably gone over that particular roundabout at Marsh Mills and seen those sales there if you're going down the A38 Devon Expressway. And the site's also part of a major commuter route which is helping to connect the eastern part of the city with the port and city centre and the waterfront. And it's also used to connect the north and the south, avoiding some of the congested routes on various other parts of the city. So it's a very, very important gyratory within Plymouth. The roundabout is also located at the gateway to both the Marsh Mills Retail Park and the Coypool Retail Park, which add to the pressures on that particular roundabout. And there are several sort of fast food outlets there, and traditional home and retail business stores on site as well. The original funding and the original idea for the scheme came from a 106 agreement with Plymouth Stock Quarry, and part of the planning conditions there imposed by the City Council and the National Highways was the 106 funding to provide mover on and around part of that scheme. And as many of you will know, the mover funding or the 106 funding was agreed without any kind of real investigation, a detailed investigation. So it was a little bit finger in the air. Let's go for this amount of funding. As we move into the presentation, you'll see that wasn't quite enough. So the challenge there was Marsh Mills was previously operated with three aging Siemens 800 controllers, I think it was there. And the controllers ran a series of UTC plans from 6:30 in the morning till 7 o'clock at night, with a fallback to VA outside of these hours. The detection for the VA was provided by MVDs and stop line loops. So any mover loops that they wanted to install were going to require a large amount of ductwork, especially as several of the approaches have at least 5 lanes. Not only would new ductwork be required, but there were further complications as well. And one of these was the use of the GST2, I think you call them TREEF curbs on the northbound approach from the city centre, meaning that any links to any ducting in the carriageway or loop boxes, etc., would be harder and more costly to install, as you couldn't cut into the curbing. The second challenge was the bridge deck. You see it there, it's the off-ramp from the A38 in the east of the site. Well, previously some ducting had been provided on this. The approach to on the approach to the deck, they'd still have issues with getting some in loops on that particular section as well. And the off-slip there is part of the National Highways network, and therefore, had there been any subsequent loop maintenance required on the slip road, it would have required road closures, TM, diversions, etc., etc. So above ground detection alleviated many of the potential issues that they may have there. The Plymouth southbound approach. In 2017, the signal design was carried out initially on behalf of Plymouth City Council by JSTSM company, and design relied on traditional inductive loops, which was a requirement of Plymouth at the time. The design was then priced by the Plymouth City Council's Highways Group, and it was apparent at that point that the funding provided, as I said earlier, was way under the requirement that was actually needed. So they had to rethink the detection, and they wanted to save on the civils costs in particular, and especially for things like the ducting. So they decided to stall the scheme for a while further funding avenues were explored. But also during this period, the Eastern Corridor scheme from Marsh Mills into the Plimpton area of Plymouth was progressing. And as part of that, there was a provision of additional lanes on the A38 eastbound from Plimpton, and that gave Plymouth the opportunity of having ducting installed for mover on that particular approach. And that allowed them wider communication links on the Plymouth Road from Plimpton during that particular project. So as part of the Plymouth City Council success, Transforming Cities Fund, or TCF, the successful bid that they had for that, they started to do a lot of work with JSTSM, Matt Williams, and they provided mover on several other aging sites in and around the city. Those key sites were very important to Plymouth at the time, and they had similar issues with ducting, etc. And Matt Williams fortunately had a lot of experience using smartmicro radars, and he suggested that to Plymouth at the time when this scheme was coming up, and it allowed Plymouth to engage with us and SWACO to discuss the potential of solving their detection problem at Marsh Mills. So the choice of technology, they decided to go with the what's called the UMR 11 series of multi-lane radars, and they had considered other detectors and other detection technology, but they had too many reservations, and they moved forward with those. The successful deployment at Marsh Mills has actually resulted in a cost saving to the City Council. These are his figures, by the way, not mine. City Council, somewhere in the region of £150,000. And I'm pleased to say that this installation has been operating for 18 months with no issues. That's the end of Nigel Taylor's bit. So that was the Plymouth City Council, or the official word for Plymouth City Council. And now we'll sort of hand over to me, if you like. So this slide here outlines the various products within the UMR 11 series. And this was a series of radars that were chosen for the Marsh Mills roundabout detection, mover detection. You can see that the radar patterns on the left are from our 24 gigahertz range, and there are two detectors in there, type 44 and a type 45, which differ by lane coverage and range. And then the radar on the right is our type 132 at 77 gigahertz. Some of you may know it as the MLR. By one of our OEM partners sells it as the MLR, and as I said, that's at 77 gigs. And that actually gives you a choice in software of medium range or long range. Medium range giving you a wider coverage for more lanes. Typical mounting on this, we use a 3-meter extension pole above the traffic signals. which allows us, where permitted, which allows us, where permitted, to use a ladder. Our engineers or partners' engineers install the wiring and then push the radar up into place and then secure it down when it's aligned. That also helps to alleviate any potential problems from obscuration. So when we do our survey on the site, we make sure that we can see all lanes clearly. Now that brings me to the actual plot for the actual site itself at Marsh Mills. It's currently our largest single radar site in the UK. There's 10 radars on this site. It's a fairly complicated site, and what you see there is the drop and drag Google image, which we drop into our software to allow us to actually plot the radars. The radars themselves are plotted on an individual basis, so they're not that small when you actually see them within the software. They're plotted on an individual basis there. Each radar type is selected from the drag and drop. We drop them into position. We can see then what the coverage of the particular radar is. Our engineers, they tend to call them after foods. So you get our long-range radar, narrow beam covering up to 4 lanes. That's a hot dog. They've got another one there which they call the hamburger, which covers 6 lanes, shorter range. And the MLR, the 77 gig ones, they see that as an eye because of the shape of the particular beam itself. So the other thing to consider here is that multiple radars can introduce interference, crosstalk between radars, etc., etc. Well, within our software, the patented software within smartmicro actually identifies the potential for crosstalk between radars, and a bit like a walkie-talkie, if you like, you can actually change the channel within the radar. So mixing 24 gigahertz radars and 77 gigahertz radars on the same site is quite good because you're actually reducing any potential for crosstalk. The other thing is as well, you can get interference on radars from in-vehicle comms, for instance, and from other sites around the area. We've seen that happen from time to time as well. But we're pretty convinced that we tend to cover this very, very well within our particular software. You'll note also that I said we mixed the frequency of the radars, and on the southeast corner of the site there, just here, that's an exit from the Sainsbury's site, which is here, and it's a signalized exit. We've got a 77 gig radar on there. And we actually, on that particular one, we lowered the angle of the radar. So we call it almost like it's looking for its toes, which gave us coverage of the stop line and the exit loop, which was at 18 meters, I think it was, on that particular exit. So there's a mix of radars on the junction. You'll see them. You should see 10 of them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There they are. So that's the positions of each of the radars on that site. Different choices for the different beams, multi-terrain approaches, and as we then program each of the radars, we upload that information to the radar itself. It doesn't upload the map; it only uploads the actual info. Within the software, within the radar software, it's a very intuitive traffic UI software, and it enables a configuration of single radars, radar by radar. As I said, you don't have to do the whole site at once. So it's radar by radar, and the traffic UI installation wizard actually simplifies the planning and allows operators to select the right radar, B, it assists them with setting out the actual lanes. the lanes and the detection, the areas of detection. You can replicate lanes, replicate areas of detection across the product, and there is also a help wizard within the software. If you get stuck, you can have a look at what's needed as you move forward. You also set the triggers. You'll see at the top here boxes as the triggers are activated. You'll see the trigger activated there, and we have the classifications down here as well. So it's each of the triggers can be assigned to various detection zones, and that allows the operators to set up to 8 triggers per detector. The next part of the software allows the lane configs here. You'll see here that the lanes are actually laid into the Google Map, and we just use the Google Map as a guide. But you can actually bend the lanes as well. Clearly, you can't see around corners, but you're actually telling the radar that there's a corner there and that traffic is going to approach from that angle. And I've got a red light on here as well, so I'm going to have to speed up a bit. Coming to the final bit now, the detection zones are also set. The detection zones are also set within the software on a radar by radar basis, and that brings me to finally, thanks to Richard Bounds of Plymouth City Council, Matt Williams, Swarco, and the guys there who assisted us with the installation. Pleased to say it's working well. As I said, it is our biggest single installation with multiple radars in the UK at the moment, although we are planning a 14 radar site currently. John, sorry.
Fantastic. No, you bang on time, Pete. Bang on time. Thanks ever so much. I'd be disingenuous not to allow a question, but it'll have to be a really quick one. Has anybody got a quick question for Pete? The one down at the end here. That's great.
Yeah, Bob Foy, Coventry City Council. In the absence of an updated Google map, what do you use?
You can actually drop a PNG into there as well. I should have said that, sorry. So you can drop your own drawing into the software as well.
Thank you.
Brilliant, short and sweet. I'm sorry we're having to cut it so short, but Pete, go and see Smart Micro UK. I mean, they've got an exhibition stand, all the kits on show.
Yep.
I'm sure I'd love to answer some questions. Go and see him at lunchtime. Thanks ever so much once again.
Thanks.
Thank you.
And yeah.